In today's video, we're going to talk about how we can use the information we learned from balancing equations and relate that to the idea of moles. Even if we go back to our last video and look at this balanced equation right here, one of the things we could say here is that one particle of D reacts with two particles of F2 to make one particle of dF4. Or, instead of just one particle, usually you don't have just one particle, you've got lots and lots of particles. So a more common way of saying this is saying that 1 mole of D reacts with 2 moles of fluorine to make 1 mole of dF4. So that means that for every 1 particle of D, whatever that is, you're also going to need 2 moles of fluorine, F2, and that's going to make 1 mole of dF4. Okay, and so we're going to use that to help us to do some math involving, again, the balanced equation and the mole concept that we've learned. That really, remember, a mole is equal to just that number, 6.022 times 10 to the 23rd. Okay? Now, there's actually 3 different ways. I didn't put the third one in here, but we've learned 3 different ways to calculate moles. Okay, one of them is by taking the grams of something. So you have 25.0 grams of zinc, and then you put the molar mass, 65.4 grams, in 1 mole of zinc, and that gets you moles of zinc. So that's one way that we've learned how to calculate moles, is if they give us the grams, you use the molar mass, you divide, you get moles. Okay, another way that we've learned, oh no, I do have all 3 of them here, sorry. All 3 of them here. Another way is to take the molarity. Say you have a 2.5 molar solution. Well, that's 2.5 moles per liter. And then you multiply by the volume. Let's say it's 1.25 liters or whatever. And you'll notice that the liters here cancel. And what are you left with? You're left with moles. So by taking the molarity and multiplying by the volume, that's a second way that we found to find moles. And then our third way is to use PV equals nRT to solve for N, which we know is equal to the moles. So you would take the pressure, let's say again 1 atmosphere, again just to kind of see the unit. The units here at 1.25 liters again. R, remember, it's 0.08206 liters atmospheres over Kelvin mole. And then the temperature would have to be, I don't know, 295 Kelvin. Okay, and then you'll notice liters, liters, atmospheres, atmospheres, Kelvin, and Kelvin. What's left is you're left with moles. Okay, so 3 different ways to start these problems is by starting with the grams, which you convert to moles, the concentration and volume, which you convert to moles, or the pressure, volume, and temperature, which you convert to moles. Okay, and using these moles, we are now going to do what's called stoichiometry. Now, stoichiometry is really, really easy. You probably already understand it. If you understood what I talked about in terms of 1 mole of this D particle plus 2 F2 particles makes 1 dF4 particle, or mole, then you understand the concept of stoichiometry. Okay? Let's look at an example here. So here this says 1 mole of methane. Again, no number in the front means 1. So 1 mole of methane reacts with 2 moles of oxygen to make 1 carbon dioxide, a mole of carbon dioxide, and 2 moles of water. Okay, and that's the important part there, is using that balanced equation to understand exactly what that says. Okay? And so we can use these mole ratios, the ratio of one reactant to another reactant, or a reactant to a product, to figure out, to basically go from any of those reactants or products to any of the other ones. For example, look at example 1 here. Calculate the mass of water produced when 34 grams of methane is burned. So again, methane is CH4, and you've got 34 grams of it. So again, anytime they give you grams, what's the first thing that you must do? You must convert those grams to moles. So you can see that's my first step right here, is I take the molar mass of methane, which is, again, has a molar mass of 16. So I put 16 grams of CH4 on the bottom, and that's equal to 1 mole on the top. Okay, and then this step right here is my stoichiometry step. Okay, that's my step where notice that I'm converting. I'm using my balanced equation and I'm converting from one of the components of that reaction to any of the other components. I could convert from moles of CH4 to moles of O2. I could convert from moles of CH4 to moles of CO2. But because the question's asking us about water, I'm going to convert from moles of CH4 to moles of water. Now, notice that anytime you use the molar mass, that's always the mass in 1 mole. Don't ever use this balanced equation up here to determine the number of moles when you're using molar mass. Okay, molar mass, and you'll see it here too, the molar mass, anytime you use that, it's always the mass in 1 mole. The only time it's not 1 mole is when you do this step right here. And again, this is the stoichiometry step. This is the step where you're using stoichiometry, which again sounds super fancy, I know, but it's not. Where you're just using the balanced equation to go from moles of one component of that reaction to moles of something else. Okay, and you'll notice here, where did the 1s and the 2 come from? Where's this 1 and this 2 come from? It comes from the balanced equation. 1 mole of CH4 makes 2 moles of H2O. That's where those numbers come from the coefficients in the balanced equation. Okay, because now, again, as I'm doing this, I should be canceling things. If I'm writing this correctly, and again, a lot of times students mess up because they're not showing their units, but you should see that as you're doing this, you're canceling units along the way. Okay, because now I have moles of H2O, so what's my next step is I have to put moles of H2O on the bottom and the molar mass of water on the top. And again, notice how moles of H2O cancel, and I'm left with grams of H2O. So now I can just go to my calculator, and I'm going to take 34, and I'm going to divide by 16, and I'm just going to go left to right. So 34 divided by 16, remember, ignore all the 1s, and then there's a 2 on the top, so I'm going to multiply by 2, and then I'm going to multiply by 18, and I get 76.5 grams of H2O. Okay, example 2 says using the same balanced equation from above, calculate the mass of oxygen required to produce 2.23 grams of carbon dioxide. So notice in this one, we're actually starting with a product, and they're asking us about a reactant, which again is perfectly fine. They can start with any of those 4 and ask you about any of the other 3 that are left. Okay, so if we're starting, we're going to produce 2.23 grams of CO2. Then my first step, again, if I don't have moles, again, they might give me concentration and volume. They might give me pressure, volume, and temperature. In these first couple examples, we're starting with grams, and we have to convert always to moles. So the first thing I'm going to do is I'm going to put the molar mass of CO2 on the bottom. There's 44 grams in 1 mole of CO2. And now my next step, I'm not going to write a number yet. I'm just going to put moles of CO2 on the bottom. And then on the top, I'm going to put moles of, what are they asking me about? Well, they're asking me about the mass of oxygen. I can't go to mass yet, but I can go to moles of oxygen. Every time you do this stoichiometry step, which again, that's this step right here, you have to go moles of one thing to moles of something else. You can't do anything different. Okay, so now that I have my CO2 and my O2, now I can go to the balanced equation. And again, based on the balanced equation, 1 mole of CO2 is going to get produced from every 2 moles of O2. Okay, so now I've done my stoichiometry step. Again, my grams of CO2 cancel, my moles of CO2 cancel. And again, whenever you're trying to figure out, well, what's my next step? Whatever these units are right here, those have to go on the bottom in the next step every single time. Okay, because now what I can do is I can convert from moles of O2 to grams using the molar mass of oxygen, which is 32. And again, notice every time that I use the molar mass, it's the molar mass. It's the grams in 1 mole always. So now I can take 2.23 and I'm going to divide by 44 and then multiply by 2 and then multiply by 32 again. And I get a final answer, 3.243, which I'm going to round to just 3.24 grams of O2. You wanted to say bless you there, didn't you? I know you did. But it's a video, so I didn't actually just sneeze. All right. So we're going to go ahead and stop right there for now. I'm going to make a separate video. Oh, no, I'm sorry. Just kidding. I'm not going to stop yet. So example 3 says 25 grams of phosphoric acid. Typically, they're not going to make you do this. Again, I want to give you a worst case scenario. How difficult could they make this problem? Okay, so they tell you the whole thing. It produces sodium phosphate, Na3PO4, and H2O. Okay, so the first thing we're going to have to do is we're going to have to balance this. So right away, let's look at some obvious ones. There's 3 sodiums. Here there's only 1, so I need a 3 there. PO4, that's fine. All total now, I count 3 hydrogens plus 3 more hydrogens is 6. So I need a 3 there, and then 3 oxygens, and there's my 3 oxygens. Remember, the oxygens and the PO4 we already took care of. So that equation is now balanced. So now we can answer the question. We've got 25 grams of phosphoric acid, so that's this one. What mass of sodium hydroxide is required? So notice in this one, we're going just from one reactant to another reactant. So we're going to go 25 grams of H3PO4. We're going to get the molar mass of H3PO4, which is 98 grams per mole. And then we're going to go, and again, this is why it's so important to use your units. It's very easy to get confused. Well, I don't know what comes next. Well, if that's moles of H3PO4, then it's moles of H3PO4 on the bottom. Okay, and then what are they asking us about? They're asking us about sodium hydroxide. So we're going to go to moles of NaOH. And then from my balanced equation, we can see that 1 mole of phosphoric acid is going to react with 3 moles of sodium hydroxide. Okay, so notice that 1 to 3 there. And then my final step, 1 mole of sodium hydroxide. Again, always notice the 1 and the 1 when we're doing molar masses is 40 grams. Okay, and so then I'm going to, again, go to my calculator. And these are all definitely calculator questions. 25 divided by 98 times 3 times 40. Make sure you get the same answer as me. I get 30.6 grams of NaOH. Okay, and that would be your final answer there. Okay, so here is just a kind of a I don't know, a little map you can follow. Is that, remember that you can, instead of just going, so this basically what we've just done right here is this. Okay, we just went grams to moles, and then using the balanced equation, we went from moles of A to moles of B, and then back to grams. Okay, but remember that you can always have those particles in there, molecules, formula units, atoms, etc., using Avogadro's number. So initially, we learned this step, these steps right here: grams to moles, moles to particles, and then particles to atoms. Okay, but now we've also thrown in a little bit of that stoichiometry as well, where you can go from moles of one thing to moles of something else. Okay, but you can only do that with moles. Notice there's no arrows between grams. There's no arrows here. Nope, that's a no. There's no arrows here. The only way you can go from one substance to another substance is using the balanced equation to go from moles of one thing to moles of something else. Okay, and then once you find those moles, again, there's lots of things you can do with those moles. As you can convert back to grams. Sometimes, if you find the moles and they give you the volume, you can go back to finding the concentration of that solution, or you can use PV equals nRT to do that as well. Okay, so I'm going to do a couple more examples, but I'm going to make it in a separate video just so this video isn't too long.